So we've already talked about inverse sine, so that was the first 3 pages. We're going to look at the next 3 pages in your notes. So let's go ahead and flip it over to example 7. And we're going to start by looking at cosine. So today we're going to finish up cosine and tangent inverse. So inverse cosine, inverse tangent. Okay, so with example 7, it says draw a couple cycles of f of x equals cosine x, which we've already done down here. And again, you're going to have to find a convenient one-to-one interval that contains the cosine ratios. We technically did this on the last page whenever we were looking at sine. We found a convenient one-to-one ratio that was pretty much close to the origin or the y-axis. So that way we can pretty much have this function pass the horizontal and vertical line test. As of right now, same thing with cosine. It would pass the vertical line test if you draw vertical lines, but the horizontal line test, if, for instance, if you use the x-axis, it's not going to pass. So what I need to do is kind of restrict this so that way it will actually pass the horizontal and vertical line test. So you want to pick something that's close to the y-axis. There's nothing really going through the origin, so I'm just going to pick on the positive side of cosine, this interval from -1 to +1. So -1 is down here, +1 is here. And that's the interval that it tells us to restrict at the top. This should not say sine, this should say cosine of x. So I'm going to redraw this interval, this small piece, over here to the far right-hand side. So I'm going to scoot this over, and I'm actually going to redraw it so that way we can see what we're looking at. So over here we have the point 0, 1. So I'm going to plot that point 1 first. Here's 0, 1. Next, we're going to plot this point. Okay, so this point here, here's pi, here's 2 pi. So this would have to be pi over 2. So this is at pi over 2, 0. That's right in the middle. Pi over 2, 0. And then the last point that I have in that interval for yellow is going to be at pi, -1. So here will be pi over here to the end. And -1 will be somewhere down here. I'm just graphing that interval from my cosine curve, so it should look something like this. Okay, so let's talk about the domain and range. Carlos, what's the domain for this graph? Let's try it again. Domain from where? 0 to pi. So 0 to pi. And what's the range? There we go. We talked about this before. In order to get, this is for our cosine graph. This is for cosine of x, or cosine of theta, if you want to write it that way. Theta and x are just an unknown angle. If I wanted to do the cosine inverse, so if I wanted to do the inverse for this, what did we do with the x's and y's on the last page for sine? We switched them. So we're going to do the same thing here. When we reflect this across the line y equals x, we're just switching the x and y coordinate. So we're going to do the same thing here. So let me label all of my coordinates that I just graphed. This is pi over 2, 0, pi, -1. We're going to take each of those points, those coordinates, and we're going to switch them. Before I graph these, keep in mind I need to have a pi over 2, and I want this graph to look nice. So I'm going to divide all of these y values, which are along the y-axis, by 2. So that way my graph is just a little bigger. Okay, we're going to start out with 0, 1. We're going to switch the x and y locations, so it becomes 1, 0. Next, we're going to switch the pi over 2 and 0. That's going to become 0 pi over 2. And then the last one is -1 pi, which is -1 pi, because 2 over 2 reduces to pi. All I would do for here is just recreate that curve. And this would be my inverse graph in blue. Cosine inverse, like we said before for sine, is the same thing as arc cosine. The only difference between arc cosine and arc sine is just the trig function. So arc is going to be your note that it's going to be an inverse. Chelsea, what's the domain for this arc cosine blue graph? What's the domain? -1 to 1. And what's the range? Go from the bottom to top. Bottom of this graph is starting where? Along the y-axis. Look at what I'm doing. Down here, this is the bottom of your graph. Where is it starting on the y-axis? starting down here at 0, and it's going up to pi. So that's your range. So just like you saw with arc cosine, it's going to be doing the exact same thing. It's going to be going from your domain in the original function is now going to be the range for the arc cosine or the inverse cosine. And range for the original function is going to turn into the domain. So that's why you're switching the x and y. Just like we see up here for your range, going from 0 to pi. 0 to pi now in the unit circle is in the first 2 quadrants. So it's going from quadrant 1 to quadrant 2. That's a little different from arc sine. Arc sine was in quadrants 1 and 4. Now we're looking at quadrants 1 and 2. So we're going to take this information and a highlighter, and we're going to kind of move over to the next section. All right, so in this next section down here, it asks you for the inverse cosine. So the inverse cosine is a function that's represented by f of x equals cosine inverse of x. The domain of this is from -1 to +1. And the primary value range or principal value range is from 0 to pi. This means that your cosine or x is your cosine ratio, and f of x is your positive angle that's either acute or obtuse in quadrants 1 and 2. Because remember, in quadrants 1 and 2, you can create either an acute angle or obtuse. And then this last sentence is what we saw for inverse sine. For inverse cosine, it can also be called arc cosine. So I can write this as, not sine, we actually write this for cosine. This could be rewritten as cosine inverse of x equals arc cosine of x. These two are the exact same. You're not changing anything by writing those. All of this stuff so far is the exact same thing you've seen before. All we're going to do now is worry about example 8. So with example 8, if you look at all 4 of these all have a cosine inverse. So for cosine inverse, let me write this out. The number that's in the parentheses here needs to be a ratio. So for cosine inverse, that needs to be a ratio. I want to write this out, even though I didn't do it for sine. This is between -1 and +1, because I want you to keep in mind where your values are supposed to be between. Okay, if we think back to last class, before we just started finding all the answers for these, we first double check to see if the numbers that are in the parentheses or next to your sine or cosine, whatever it is, if they're ratios or angles. So square root 3 over 2, this is a ratio. -1/2, that's also a ratio. 0. Well, technically 0 could either be a ratio or it could be an angle. I could pull that up on your unit circle chart. The great thing about 0 is you get to choose. With this cosine inverse being here, what do I need this to be? You need it to be a ratio, so we can make this a ratio. If this was just cosine, so don't write this out, but if this was cosine of 0, what would you need this 0 to be? An angle. So we would just make it an angle. I would probably just put right radians behind it and we would be good. We're going to have some questions today where we actually have to make that cosine a ratio or an angle when it's not already given. And then the last part is 5 over 7. That is also a ratio. All right, Enya. After we label all of these, I need to determine, are each of these numbers in this domain? So in this -1 to +1 interval. So square root 3 over 2, is that in this interval? Yes, it's 0.8 something repeat, or 0.877 or something like that. So yes, that's in that area. What about 1/2? Is that between -1 and +1? Yep. What about 0? It's right in the middle. And then what about 5 over 7? Yes, it might not be on my unit circle chart, but it's there. All right, before we actually start solving these, hopefully you guys remember, we're going to need to create our unit circle chart. We're not going to create the whole thing. We just need it for cosine of theta. So in this space, right below, next to this little chart, we're going to go ahead and recreate that. Cosine counts down, 4, 3, 2, 1, 0. All right, so let's start. So for the first question, it pretty much says, for this, you're going to have to find some angles. Let me kind of refresh your memory back to what we did on the first page. Cosine inverse of some ratio, we did this on the very first page with sine. This is the same as cosine inverse of some ratio, needs to be solved for some angles. You should be getting an angle measure when you solve this. So even though I had sine on the first page, it means the same thing for any trig function. Sine, cosine, tangent, all of the reciprocals as well. So Odalis, looking at your unit circle chart that we just created, when is cosine going to be square root 3 over 2? Pi over 6. Okay, so before I write that down as my answer, here's pi over 6. I can technically use any answer from 0 to pi. What's the angle that I can kind of use that represents pi over 6, but in quadrant 2? So let me ask you two things. What symbol, positive or negative, is square root 3 over 2? It's positive. So where will you get a positive cosine? In quadrant 1 or quadrant 2? Quadrant 1, because in quadrant 2, what happens to cosine? What does it become? Negative. So we can't use 5 pi over 6, but we can use pi over 6. That's our answer. Let's do the same thing with the next one. Okay, this one is a negative 1/2. Be careful with that. Carlos, where will cosine give you a 1/2? Pi over 3. Okay, so let me graph this out. I have pi over 3. I can technically use any number between 0 and pi. So in quadrant 2, where will you see the same coordinate as pi over 3 show up, but in quadrant 2? What's the angle measure? Oh, thank you, Carlos. Your voice has traveled. All right, Carlos. So at 2 pi over 3 and pi over 3, which of the answers should I probably use if I'm trying to get a negative 1/2, Carlos? Quadrant 1 or quadrant 2 answers? Quadrant 2. We can't use quadrant 1 because all of these answers will be positive, so the answer we need is 2 pi over 3. That's my answer. You guys try the next two. I'll give you a hint. For letter D, try to draw out a triangle. It might help. All right, so for cosine inverse of 0, Euridia, what did you get for cosine inverse of 0? Pi over 2. Is there another answer we could use, or it's just pi over 2? Okay, so you're correct. It's neither negative nor positive. Cosine or ratio for this is 0, so we're just using it as a ratio. Pi over 2 is here. Pi over 2 is the coordinate 0, 1. Do you agree with that? Okay, so yes, technically it's not negative or positive, but we can only pick numbers that are between quadrants 1 and 2, so between 0 and pi. Where else will you get another cosine, which is an x-coordinate, that's 0? What is that? It's negative pi over 2, or what else could you say it is? 3 pi over 2. Negative pi over 2, 3 pi over 2, it's the exact same location, so you're absolutely right. What's the coordinate here? 0, negative 1. Let me ask you this, though. Is this between 0 and pi, like we said that cosine inverse needs to be? No, that's why we can't use it. There is another one, but we can't use that value because it's not between 0 and pi. It needs to be in the first two quadrants. Good job, though. It is pi over 2. That's your only answer. For letter D, when you guys graphed this out, it probably looked something like this. Here's theta. Arc cosine is the same as the adjacent side over the hypotenuse. So this is 5 over 7. Normally, and let me kind of refresh your memory as to what we did last time, on this part down here, when we had something we had to do a triangle for, we had something else to find, like cosecant or tangent or cosine. Do we have that here? At least not right now, no. So what this is asking you to do is actually find out what theta is. Theta is cosine inverse of 5 over 7. We had this conversation last time. Cosine inverse is equal to 5 over 7. Think back to when you were in geometry. If your geometry teacher gave you a question like this, besides crying, what would you do? What would you use? You would use calculator. No, you're not going to use SOHCAHTOA. You already used SOHCAHTOA to actually create your triangle. You had to use a calculator for this. What the problem is telling you to do for this question, guys, is to use a calculator to find the actual angle measure, which in this case would be theta. So in your calculator, I'm telling you now, guys, on tests and quizzes, I probably won't give you a question like this because you're going to need a calculator. If I give you a question on a homework or on a test or excuse me, on your final exam, you'll definitely have a calculator for it. So let me show you guys how to find it. We're going to go into a calculator. Since the directions, and you guys can confirm with me, it just tells you to find the answer. It doesn't tell you to write it in radians or degree. So what we're going to do is I'm going to actually find it for radians and degree for both of them. So the first answer I find, my calculator is already in radians, so I'm going to start off by finding it in radians. We're just going to put cosine inverse of 5 over 7. Okay, so write this out. This will be 0.7752 radians. I just rounded that. So 0.7752 radians, in case it asked you to solve it for radians. If it asked you to find it in degree, what would you have to do to the calculator? Put it in degree mode. So I'm going to go down to settings and change document settings. We're going to change this to radian into degree. I'm going to tab all the way over to OK, and I'm just going to copy this down and recalculate. This will give me 44.4153. And I'm going to put that degree symbol behind it. Notice I put radians, RAD, behind the radian answer and degree behind the degree answer. On your tests and quizzes, guys, if I gave you a question like this, that's all you can do. So write that answer and then move on. Give me some nods or shakes. Does this make sense with what I'm doing so far? All right, cool. Let's go ahead and look at the next part. So at the bottom, this little chart, you've already seen it before, but you saw it as far as cosine is concerned. Our goal is to still be able to cancel out your arc cosine and your cosine, but you want to make sure, like we did on the last page, that if you have an arc cosine, that this is a ratio, not an angle, that this number is a ratio, and that that ratio lies between -1 and +1. You also want to make sure that if you have cosine, that the number next to it is some kind of angle. And you also want to make sure that that angle lies between 0 and pi. So let's figure out what we can do. On the next page, I'm hoping for at least some of the questions we can cancel out both the cosine and the arc cosine, but we'll have to see when we get to the next page. So when you're ready, go ahead and flip it over to the next page. All right, so at the top up here, I'm going to do two things. First thing I'm going to do is write out, when you have cosine inverse, the number inside needs to be a ratio. And that ratio needs to be between -1 and +1. When you have cosine, the number that's in that parentheses needs to be an angle. And that angle should be between 0 and pi. I'm going to keep asking you guys to check to make sure that these restrictions are being met. So before we do anything, I'm just going to look through all of the questions and I'm just going to check them. First thing I have here, this is an angle. This question is also an angle. This is a ratio. This is an angle. And this is a ratio, or not ratio. Let's try that again. I switched it. This is a ratio. The other one's an angle. Ratio, angle. Double check my label, guys. Make sure it actually makes sense. All right, I've labeled all of my items. Now what I need to do from here is actually need to double check. Cosine has an angle, that matches. Is this angle between 0 and pi? Yes or no? Yes. Okay, so I'm going to put a little check mark. I can actually solve that. For cosine, the one that's next to 7 pi over 6, it has an angle next to it. Perfect. Is this angle between 0 and pi? No. Put a little x. This cosine should have an angle next to it. Wait, what do we label this as? A ratio. Well, that can't exist. If you have cosine, so notice here, this says cosine, right? No inverse. Cosine needs to have an angle next to it every time. Since this doesn't have an angle, I'm going to put an X and I'm actually going to label this as it does not exist. The reason why I'm automatically labeling that as does not exist is because you cannot find cosine of some ratio. You can only compute this if it was cosine inverse of some ratio. Since it's not in the correct form, it's not cosine of some angle, we're just going to write does not exist. If it's any question, so for instance, if it was cosine of square root 3 over 2, you would put does not exist. If it was cosine of 1/2, does not exist. This number next to cosine must have an angle measure every single time. Arc cosine, this is a ratio, that's good. And this is between -1 and 1. And then for this one, cosine does have an angle. Wait, is this between 0 and pi? No, okay. So the good news is the ones that have checks next to it, we can just cancel out the arc cosine and the cosine and write our answer. So we said before, this 3 pi over 4 is in between 0 and pi, so I can cross out the cosine and the arc cosine and just write my answer, which will be 3 pi over 4. What other question can we do that to? Letter D. Letter D was the only other check mark I gave. The 1/2 is in between -1 and 1. and it's arc cosine. It's a ratio, so I can cancel this. So my answer would just be negative 0.5. Or you could write it as a fraction, which is negative 1/2. Okay, there's really only 2 questions I have to work out. So let's work out the 2 questions that we need. Over at letter B. So I'm going to kind of zoom in a bit. So for letter B, it says cosine of 7 pi over 6. Okay, so really quick, let's graph this out. David, what quadrant is 7 pi over 6 in? I'll give you a hint. Here's 0. Here's 6 pi over 6. Yes, third quadrant. Here's 7 pi over 6. Let me ask you this, David. In 7 pi over 6 in that third quadrant, what symbol, positive or negative, will cosine be? Negative. Cosine down here is going to be a negative answer. So we need to find our answer, David, in quadrants 1 or 2 that will give me a negative cosine. So let's start simple. What's your reference angle for 7 pi over 6? Where would you reference that in quadrant 1? But at pi over 6, what symbol will sine be? Or excuse me, cosine be? Cosine in this quadrant will be positive. Okay, I can't have that. That's not going to be my answer, so let's look in quadrant 2. If you're using pi over 6 as your reference angle, what angle will you use here that will give you the same quadrant as pi over 6, or same coordinate? So here's 5 pi over 6. Will cosine be negative here? Yes, cosine will be negative. Well, if that's the case, my answer is just 5 pi over 6. That's it. The letter E, same process. Okay, first let's graph this out. This is definitely bigger than pi. Okay, so here's 0. Here is 7 pi over 7. Okay, let me add 7 to that. This will be 14 pi over 7. What's 7 plus 14? 21. So here's 21 pi over 7. 23 pi over 7 will be somewhere about here. 23 pi over 7. Okay, let's keep it simple. Valeria, in quadrant 3, what symbol, positive or negative, will cosine be? Cosine will be negative. So what we need to do is figure out in quadrants 1 and 2, what will be our same angle that we can use that will still give us a negative cosine. Okay, so this one's a little different. Valeria, what's our reference angle here? Yep, 2 pi over 7. Because if you're going from the pi down to 23 pi over 7, that's the same as 21 pi over 7. So it's just 2 pi over 7 units. So this will be 2 pi over 7. Okay, so Valeria, in this quadrant, is cosine going to be positive or negative? Cosine's positive. Can we use this as our answer? No. Okay, let me cross that out. Let's go into quadrant 2. If I was to look at pi or 2 pi over 7, I want to find an angle that's similar to that in quadrant 2. What would our angle measure be if it's in quadrant 2? How'd you get 5 pi over 7? Just subtract 2 pi over 7, guys, from 7 pi over 7. It's in the same location, so this distance should be the exact same. Okay, so double check, Valeria. Is cosine going to be negative in this quadrant? Yes, it will. So since cosine will be negative here, your answer is 5 pi over 7. All right, next part. So all of this is for cosine. We're going to do some more things with cosine in just a second, but let's go ahead and move on to the bottom portion. Let me zoom out for a second and look at part 10, example 10. So example 10 says, draw a couple cycles for f of x equals tangent of x. Okay, we've already done that here. Before I do anything with this graph, guys, what's missing? There's a few things that are missing in this. What's missing? Say it again. Asymptotes. Your asymptotes are missing. So one thing I'm going to graph in black are all of my asymptotes. And I'm also going to make little arrows because technically these graphs are going to continue going up and down. And I'll also continue with my asymptotes. You guys literally have this in your notes for your tangent parent function. So what it's asking you in the directions at the top, you need to find a convenient one-to-one interval that will contain all of the trig ratios. And for this, you want to look for the interval between negative infinity to positive. And remember, this is along the y-axis. Okay, so remember, I said that you guys need to find something that's pretty much close to the y-axis or close to the origin. Since one cycle for tangent goes from negative pi over 2 to positive pi over 2, we're going to use this middle portion here. And I'm going to recreate this on the far right-hand side. So over here, let me regraph it. Here's going to be our one-to-one interval because as of right now, it'll pass the vertical line test, but it will not pass the horizontal line test. If I just have one cycle for this, I'll be able to create a one-to-one function. So this will be over here at, okay, let me look at the graph. This asymptote is at negative pi over 2, and this one is at pi over 2. So let me graph my asymptotes. Unlike the other graphs, they weren't as, or this one's not as pretty, because I have the origin as a clear point, but the issue is I don't have another one. You could look up the graph and you could look down the graph. I don't have another clean point. So I'm just going to use this entire interval. Think back to algebra 2. This curve, what is it called? Say it again. It's a cubic function. So down here, this is y equals x cubed. So let me go ahead and graph that out. With a cubic function, it starts at the origin, it curves up, and it curves down. This is your cubic function. All right, before we do anything else, Giselle, what's the domain for this curve? Be careful. Go from left to right. Negative pi over 2 to positive pi over 2. But are you going to include those values or not? Why not? They're asymptotes. You cannot include something if it's an asymptote. What's the range for this? What's another way I could write negative infinity to positive? All real numbers. Either one of those will work for me on a test or quiz, guys. Beautiful. That's my graph. The issue is I now need to do the inverse. So in order to do the inverse for this, I'm going to have to flip some things around like you guys just told me. In order to do the inverse, which is reflecting it, I need to switch the x and y coordinate. Okay, well, there's an issue here. In order to switch the x and y coordinate, I need to have something more than 0. So remember how we said that this is the cubic function? What's the inverse of a cubic function? Cube root. It's a cube root function. What does a cube root function look like? Show me with your hands. What does a cube root function look like? It's close to this, but it's just a little different. It looks like an S. Literally just looks like an S, which we're about to graph. So for each of these, okay, let me keep in mind this is between negative pi over 2 and positive pi over 2. So I'm going to divide all these by 2. And the positive pi over 2 and negative pi over 2, these are still my asymptotes. You can't change that. The curve itself that was in the middle, though, we can actually create a cube root function. So with cube root functions, it starts at the origin, it curves up this way, and then it curves down this way. This is a cube root function. In this space, before I do it, label your domain and range of this blue graph that we just made. Label your domain and your range. What's the domain for this arctangent graph? What's the domain? Read it from left to right. Negative infinity to positive. What's the range? Go from the bottom of the graph to the top. Negative pi over 2 to pi over 2. Remember, these are the same increments. This is just negative pi over 2, negative 2 pi over 2, which is pi, and so on. Okay, so this is our graph. With this graph, it has a restriction. So this is tangent. This is the last trig, or of the normal kind of trig functions. So with this one, it's going to be in the first quadrant and the fourth quadrant. So quadrant 1 and quadrant 4. With those quadrants, though, remember, the range of this is not including your endpoint. So I'm going to put a big circle here and a big circle here. Notice that both of those circles are open. You are not going to include the values at pi over 2 nor negative pi over 2. You can't include them. Last thing I'm going to do is just highlight some of the same information you've already seen, but we're going to do this for tangent. So for inverse tangent, we have f of x equals tangent of negative x, or excuse me, tangent inverse of x. The domain is from negative infinity to positive, and the principal value range is from negative pi over 2 to positive pi over 2. You're not including the endpoints. X represents your tangent ratio. F of x represents your acute angle, because technically, since it's in quadrants 1 and 4, it should only be acute angles. And again, this is in quadrants 1 and 4. Inverse tangent is the same as arctangent, guys. So when I write this out as tangent inverse of x is equal to arctangent of x, it's the exact same thing. Both of these are the exact same. It's not different. If you're good and you're ready to move on, let's look at the next page. All right, so for example 11, let's go ahead and look at the first ones. So if you look at A, B, C, and D, you have tangent inverse, arctan, tangent inverse, arctan. Okay, that's fine. What I'm going to do at the top of the page, though, is I'm going to make a note that tangent inverse needs to have a ratio in the parentheses. For tangent inverse, if it's a ratio, that ratio needs to be from negative infinity to positive. So that ratio needs to be from negative infinity to positive. This is my favorite because it literally can be any number. It could be something as small as 1/2. It could be anything as big as 2 million. No matter what the number is, you can always do it as long as it's a ratio. You don't want to see pi here. Okay, so let me go through all of these and I'm going to write out what they are. 1 is a ratio. Square root 3 over 3, that's a ratio. 0, wait, is 0 a ratio or an angle? It could be both. Okay, so what do I want this to be, though? So let's write ratio. And then 30, it's big, but it's a ratio. Okay, so let me go through all of these questions. Edgar, is 1 in your restriction, is it between negative infinity to positive? What about square root 3 over 3? 0? 30? 2 million? Yes, all of these numbers are in there. So guys, you really don't need to check, but just check just in case. If you see a pi anywhere, guys, it's not going to work. Okay, so let's start with tangent inverse of 1. I'm going to do tangent inverse of 1 with you guys. I'll do letter D. You guys are going to do 2 in the middle. So for letter A, tangent inverse of 1, let's go ahead and figure this one out. I probably also need my tangent chart. So let me go ahead and create that here now that I thought about it. Let's create your tangent chart. Tangent of theta. Zero, 1, undefined, square root 3 over 3. I memorized these a little bit out of order, but it works for me. However you guys can memorize it is what I need. All right, now that I have my table set up, you guys can use this to help with solving for A. Okay, so Jorge, in that table that we just created, when is tangent what angle measure will tangent be when it equals 1 for your ratio? Pi over 4. Okay, let me graph this out. Pi over 4 right now is in quadrant 1. That will give you a positive tangent, correct? So tangent here will be positive. The only other place I could find an answer is in quadrant 4. Do I need the angle measure in quadrant 4? Question, do I need it? You don't need it. Why? What happens in quadrant 4? What symbol is tangent? Tangent's negative. So for this question, what do you think your answer is going to be? Pi over 4. That's it. You don't have to find the other one. I just like you guys to find it to ask yourself what symbol will it be. That'll help. You guys in a second are about to do B and C. I'm going to do letter D with you guys. We talked about this before, especially since this is arctangent of 30. Let me go back to what we did for sine. The only reason why we were able to find a better answer for these questions is because we were doing some other trig function after. Since we're not doing any additional trig function after arctangent of 30, I just need my calculator. So what I'm technically finding is your theta value for tangent inverse of 30. That's what you're finding. You did this back when you were in geometry. So let's go ahead and find it. There's going to be 2 answers I give you because the directions don't tell me which way to write it. Since this is in degree, I'm going to start out with degree. Tangent inverse of 30. Go ahead and write this out. We have 88.0908. 88.0908. This is in degree. And then I'll also write this in radians. So in order to write this in radians, I'm going to switch this into radians. And I'm going to copy this down. Tangent inverse of 30 in radians is 1.5375. 1.5375. And this is in radians. So make sure you guys put that RAD behind it to show that it's radian. All right, you guys have a brain. You have somebody next to you. Do letters B and C. I want you guys to try it first because we're about to do the ones below it. Okay, for letter B, Heidi, what did you get for your answer here? Negative pi over 6. That's exactly it. Do I need to go through why your answer is negative pi over 6? I think I do. Okay, so let's start simple. Heidi, how did you get your first part? What did you look at first? Okay, so the chart. So you're looking at the chart to see when will tangent give you an angle measure that will equal square root 3 over 3. So what did you get? Pi over 6. So if you look at your chart, square root 3 over 3 is going to be at pi over 6. So here is pi over 6. This needs to be, only our answers for tangent need to be found in quadrants 1 and 4. So those are only 2 quadrants. What did you do from there? Why didn't we keep pi over 6 for your answer? What's wrong with that one? Tangent right here is positive. Okay, so we can go all around the unit circle, but the only answers that will be valid are in quadrants 1 and 4. And when you're going for 1 and 4, it has to be between negative pi over 2 and positive pi over 2. So by going in the negative direction, finding negative pi over 6, which is the same location as what? 11 pi over 6. So if you wrote 11 pi over 6 for your answer, you're not wrong, but it needs to be between negative pi over 2 and positive pi over 2. So 11 pi over 6 is on the right track. You just have the wrong sign. That's all. So 11 pi over 6 can't be used. It has to be negative pi over 6. Letter C. This one says tangent of 0. Hussein, what did you get for tangent of 0? Not quite. Is 2 pi between 0 or negative pi over 2 and positive pi over 2? 0, there you go. And 0 for this needs to be in radians. So put a little RAD behind it so that way I know and you know that this should be in radians. 2 pi isn't incorrect, but it needs to be between negative pi over 2 and positive pi over 2 every single time. Is that okay? All right, let's look at the bottom portion. The bottom portion here, this little chart, is saying what we've already seen for sine and cosine. The whole goal of having this chart is so you can hopefully cancel out your tangent and arctangent. You can do that if this x value, first of all, is a ratio, and that ratio is between negative infinity and positive. If it meets that criteria, you can cancel out the tangent and arctangent and pretty much just write your x. Second part down here, arctangent and tangent, these two can cancel. That's only if, though, this x is an angle. If this x is an angle and it's between negative pi over 2 and positive pi over 2, you can cancel out the tangent and the arctangent. You can cancel both of those. So we did this for cosine, we did this for sine. Let's do it for a couple of the tangent questions. Just like I did above, I'm not going to do all of the questions with you, and I'm not going to have you guys try all of the questions either. We're going to first do letters A and B, and then the other 2 questions I'm going to leave for you for another time in case you choose to do it. So for question 12, we have all of these numbers that are in radians and ratios. So let's start with 7 pi over 4. I'm just labeling it. This is an angle. Negative 1000.22. This is a ratio. It's an ugly ratio. 4 pi over 3. Negative 4 pi over 3. That's an angle. And 19 pi over 15. That's also an angle. Even though I'm not doing C and D, I can at least write out what it is. It's not going to hurt. Okay, looking at the first one. This is tangent of an angle. Okay, perfect. It needs to be tangent of an angle. And let me rewrite that so we have it. Tangent needs to have an angle next to it. That angle needs to be between negative pi over 2 and pi over 2. Tangent of a ratio, that ratio, tangent inverse of a ratio, needs to be between negative infinity and positive infinity. So pretty much any number. No, just the tangent inverse. This is the only one that needs to be a ratio. And honestly, Hussein, I just recopied it from the top. Tangent inverse. Anything with an inverse, guys, has to have a ratio in the parentheses. Okay, so let's get back to letter A. We're just focusing on the inside. Tangent of 7 pi over 4. I need to ask you guys, this is an angle, yes? Is this angle between negative pi over 2 and positive pi over 2? No, it's not. So I'm going to put a little x next to that. I can't just cancel out both of the tangent and tangent inverse. So let's try to figure out what our answer is going to be. For this one, I guess I'll go ahead and solve it since I started. Let me go ahead and graph this out. Where's 7 pi over 4? What quadrant? Fourth quadrant. Here's 4 pi over 4. So we have down here 7 pi over 4. Okay, that's a good sign. I specifically said, and let me flip back, I specifically said your answers need to be in quadrants 1 and 4. However, what's the restriction I want you to remember? What does it need to be between? Negative pi over 2 and positive pi over 2. Is this between negative pi over 2 and positive pi over 2? Okay, so how can I make it between negative pi over 2 and positive pi over 2? We're just going to find a coterminal angle, and we're going to make this negative pi over 4. That would be your answer. So all I did, guys, especially since I know it needs to be between negative pi over 2 and positive pi over 2, I just took this and I subtracted 8 pi over 4. What's 7 minus 8? 1, which is just 1 pi over 4. That's your answer. Give me a nod or shake. Do you understand why I did that? Do I need to go into quadrant 1 to find anything? Melissa, why not? What symbol is tangent of 7 pi over 4? It's negative. Tangent in this quadrant is negative. So what symbol would it be up here if I found this? Which is what I don't need. That's not what I need. All right, for letter B, we have tangent of arctangent of negative 1000.22. Valerie E, negative 1000.22, is that between negative infinity and positive? Yes, it is. So what can I do with the tangent and arctangent? So what does that leave your answer as? That's it. On your tests and quizzes, guys, if they literally cancel out like Valerie just told me, that's exactly what you do. Just cancel it out and write your answer. Portion for example 13, I'm not going to do all of these questions. I'm only going to do letter A, F, G, and H, but I'm going to do them on the back side of your page. So I'm going to make a note here so you guys don't act crazy. This is going to be on the back, if I could spell back correctly, on the back page. So I literally want you to flip this over, and we're going to do those highlighted yellow questions on the back side of this page. There's methods to my madness, guys. This isn't for no reason. On the back side of your page, we're going to combine a few things because you don't have to keep flipping it back, but I'm just going to show you. Notice here we have sine and arc cosine. If you think back to all the other questions we've done, they've just been, for instance, tangent inverse and tangent. We've had cosine and cosine inverse. And we've also had sine and sine inverse. We haven't had it where it's a combination of sine and cosine, and for some of these questions, cotangent and tangent and all the other ones. So I'm going to show you guys how to solve these specifically. Literally, all we're going to do is work from the inside out. So on the back side of the page, I want you to write out a few things. The first thing is your unit circle chart. I didn't mean for the pi over 4 to be so small, but whatever. Sine counts up. Cosine counts down. In the space at the top, I'm also going to label what your sine inverse restrictions look like. So it should be in the first two quadrants, quadrants 1 and 2. And you can include, this is why these are closed dots, these big bubbles that I'm drawing, these are closed dots. You can include negative pi over 2 and positive pi over 2. This is in quadrant 1 and quadrant 4. The domain for this needs to be between negative 1 and positive 1. I'm doing the same thing for y equals cosine inverse of x and y equals tangent inverse of x. So all of the stuff that we just talked about. Go ahead and recreate where your restrictions lie and what your domain will look like. This is an inverse, negative 1 power. All right, so I have my items drawn out. These are just the restrictions I need to keep in mind. Sine, cosine, and tangent, without the inverse, they have no restrictions. For sine, cosine, and tangent, we shouldn't have any issues that we have to keep track of. However, if we have any of these with an inverse, we're going to have to hopefully or potentially change something. So I'm going to recopy on the front side, or from the front side, letter A, which is sine of arc cosine, which I could have written as cosine inverse, of negative square root 2 over 2. When you're solving questions like this, guys, work from the inside out. So we're going to start with the inside item, which is arc cosine of negative square root 2 over 2. So the first thing we want to check is just like we did before on the other page. Is this a ratio? Because we have arc cosine. Arc cosine needs to have a ratio in the middle. Is there a ratio here? Okay, perfect. We can solve it. So we're just going to go to our handy dandy chart that we have at the top of the page. And you guys tell me, what is arc cosine? What's the angle measure for negative square root 2 over 2? Give me positive square root 2 over 2, and then we'll find negative. Pi over 4. So square root 2 over 2 for arc cosine, the angle measure is going to be pi over 4. Is pi over 4 my answer? Jenny, what do I need to do to this pi over 4? What quadrant does it need to be in order for it to be a negative square root 2 over 2? Think of the restrictions. Quadrant 2. In quadrant 2, what's the angle measure we're going to have to use? 3 pi over 4. So at 3 pi over 4, it's in the restriction for cosine. It's literally right here. And it will give you a value of negative square root 2 over 2. So I'm going to rewrite sine. And in the parentheses, Jenny, what did you tell me arc cosine of negative square root 2 over 2 is? Perfect. That's the first step. Second step. Remember, sine, cosine, tangent, without the inverse, there's no inverse here. There's no restriction. So what is sine of 3 pi over 4? First of all, it's in quadrant 2. Is this going to be a positive or negative answer for sine? Positive. What's your answer going to be if it's in quadrant 2 for 3 pi over 4? That's your answer. That's it. That's all you're doing for these. You're just solving one question at a time. Focus on the inside and work your way out. All right, let's look at one more. After letter F, guys, you are going to try G and H. So for letter F, let's do secant of tangent of pi. Secant and tangent, do either of these have an inverse? No, none of these have an inverse. So I don't need to worry about all of the stuff we wrote over here to the side. I don't need to worry about it. Just like we did before, we're going to work from the inside out. Okay, so first things first. This pi is an angle. Tangent needs to have an angle next to it. Just tangent needs to have an angle. I'm literally referencing what we just wrote. Tangent, some kind of trig function, needs to have an angle next to it. Okay. So for tangent of this angle, there's no restrictions I need to keep track of. Look at your unit circle or graph this out. What is tangent of pi going to be? Pi is over here. What's the coordinate for pi? And how would you calculate tangent at pi? Y over x. So y over x is 0 over negative 1, which is what? 0. Okay, cool. So by solving this, tangent of pi is going to give me 0. So let me write this out. Secant of something, and that something is 0. That's the value that we just found. Okay, now that I have this, I want you to keep in mind, and I'm going to refer back to your first page. Tangent of some angle, let me flip this back to the first page of your packet. Tangent of some angle needs to give you a ratio for your answer. So sine, cosine, tangent of some angle needs to give you a ratio. We have a ratio, which is 0. The issue is here, secant. Okay, well, secant has to have what next to it in order for me to solve it? An angle. Okay, so remember, 0, we could do what with this? We could make it a angle or a, but you guys told me we need what here? Okay, so let's make this an angle. And I'm going to put RAD behind that. I'm going to squeeze that in. 0 radians, RAD. This is the only question you could do that with. For secant of some angle, I'm going to go back to that very first page. For secant of some angle, you're going to solve and get a ratio for your answer. So when you solve this, guys, you're going to need to get a ratio. Okay, secant of 0. Secant is a reciprocal for what trig function? 1 over cosine. Remember, this is in radians. Let me put RAD behind that so you can actually read it this time. 0 radians. Cosine, sine, all of the original trig functions that don't have an inverse, there's no restriction. So look at your unit circle chart. What is cosine of 0? Positive 1. So we're going to make this 1 over 1 because cosine is technically in the denominator. And we would just simplify. What's 1 divided by 1? Just 1. That would be your answer. So I want you guys to do the same thing, but for letters G and H. So I'm going to rewrite letters G and H on this front page so you guys can see it. So G is cosine inverse of, I think it technically says arc sine, but I'm just going to write sine inverse because I'm lazy, of 0. And letter H is sine of 2 cosine inverse of 0.5, which of course you could change to 1/2. I'm going to give you guys 5 minutes. I want you and the person next to you, you by yourself, whoever, I want you guys to work on G and H right now. For letter G as in goat. First, I want to know what the answer is, and then I'll kind of go through and show you what steps you should have done. So, Gabrielle, for letter G, what did you get for your answer? Pi over 2. That's exactly it. So what you should have done was work from the inside out. Sine inverse of 0. So I need to know what angle will sine give me 0. You can look back at your chart. The angle that sine will give you 0 is just 0. Make sure you make a note here, since it's a sine inverse of 0, you want this to be a ratio. So you should have solved this. This is cosine inverse of 0. Again, since you have 0, you have the freedom. You can either make this a ratio or you can make it an angle. Well, since this is 0, we have cosine inverse this time. I definitely want this to be a ratio. So since this is a ratio, I can go ahead and solve. With that solving, I'm just going to look back at my chart. Cosine inverse is going to be what angle for 0? So up here, we're going to have cosine inverse, or cosine will give you 0 at pi over 2. So that's how pi over 2 is your answer. So let me highlight that so you can see it. All right, last question down here. Fatima, what did you get for H? Positive or negative? That's it. For this question, work from the inside out, guys. So on the inside, you're going to start with cosine inverse of 0.5. What is 0.5 as a fraction? 1/2. So you can do this. So I'm going to write this as a ratio, which you guys hopefully know is 1/2. I'm going to write this as sine of 2. And in that parentheses, we're going to actually write that angle measure. So cosine inverse of some ratio needs to give you an angle for your answer. And again, you kind of go back down memory lane. Sine, cosine, tangent, inverse of some ratio needs to give you an angle. So on the back side of this page, I'm going to go ahead and write out for cosine inverse of 1/2. Let me go back to my table. This is going to be at pi over 3. So pi over 3. We're going to go ahead and multiply that out. Literally, guys, just multiply. 2 times pi over 3 is going to give you what? 2 pi over 3. And 2 pi over 3 is a what? It's an angle. So with that angle, make sure you have sine without an inverse next to it. You can simplify this. So sine of 2 pi over 3, I'm going to graph this out. 2 pi over 3 is in this quadrant. And in quadrant 2, is sine going to be positive or negative? Positive. Sine is positive. So I need to just figure out what angle I'm going to reference in quadrant 1, which hopefully you guys remember is just pi over 3. So looking at my chart for sine of pi over 3, I'm just going to use square root 3 over 2. And I purposely wrote this as positive because it's in quadrant 2. That's it, guys. Questions, concerns? Really quick, guys, just a quick kind of like pro tip. All of the stuff that we wrote in red, this is the stuff that you might want to, I don't want to say memorize, but these are the things you might want to write out on your tests and quizzes when you guys take them, just so that way you remember where your restrictions are for sine, cosine, and tangent inverses. Not sine, cosine, tangent, just the original function, but the inverse functions. I would probably keep all of this stuff that I wrote in red nearby because you're going to want to write that out on your tests and quizzes. So it might be helpful.